So we now talk about the Biot Savart law. So notice that in the pronunciation this T is silent. So this is given as, the small magnetic field dB generated by a small current carrying wire ds vector. This is given as dB vector is equal to mu naught divided by 4 pi. I is the current carried by the wire. ds vector is the small piece of the wire cross product with the unit vector associated with the position where you want to find the small magnetic field divided by r square. So let us see this in the diagram. So this is the diagram of the wire. So this is the wire. So this wire is carrying a current I. You take a small portion of the wire which is ds vector. So this is the ds vector we are talking about. And you want to find small magnetic field dB at this point P. So this dB we want to find at this point P. So this point P is at a distance r vector. So the total distance here till here is r vector from the ds vector. So you convert r vector into this unit vector. So the unit vector is nothing but r vector divided by the magnitude of the vector. So this is what you call r hat, the unit vector. So now we have the Biot Savart law. So we are trying to find the small magnetic field dB at this point P. So similarly, you could pick up any other point. You could pick up a point here or here and then compute the r vector associated the unit vector r hat and then calculate the small magnetic field dB at that point. So you expand this. So you get I ds r hat magnitude sine theta. Now the magnitude of r hat is 1. This you can see because you take the magnitude of r hat. This is nothing but magnitude of r vector divided by r, because r is a scalar, and this is 1 because this we also denote by r. So since this r hat is 1, you just get I ds sine theta. So this is in terms of the scalar form. So the angle between r hat and ds vector is theta. So this angle is theta, as you can see in the figure. So again, so if you have ds vector like this and you have say r hat like this and this angle is theta, so we are taking cross product of ds vector with r hat. So we are going in the anti-clock direction. So the magnetic field will be out of the screen. So that is why we have denoted magnetic field here with the dot, noticing that it is out of the screen. So suppose the point was here. Suppose you have another point here. So in that case you would have ds vector like this and your r hat would be like this. So this would be angle theta. So now you're going from, because cross product is from ds vector to r vector, you're going in the clockwise direction. So since you're going clockwise, the force you get is in the downward direction. So this will be the magnetic field in the downward direction. So you put a cross here because you're talking about into the screen, field into the screen. Now what is this mu naught? This mu naught is nothing but it is called permeability of free space, and this is denoted by 4 pi times 10 to the power of -7 Tesla times meters per ampere. Now let us talk about the properties of this Biot Savart law. Let us now discuss the properties of the Biot Savart law. So the first property is that this B vector is perpendicular to both ds vector and the r hat. That is because this comes from a cross product. So the result of the cross product is always perpendicular to the two vectors whose cross product you have taken. Second is B vector is directly proportional to the current. This you can see in the figure itself, and it is inversely proportional to the distance. So if there is more current flowing through the wire, you will have more magnetic field at P. and if P is farther from the wire, you have less magnetic field at P. Now this magnetic field is 0 if ds vector and this unit vector are parallel to each other. So this comes from sine theta, the angle between ds vector and r hat. So if this angle is 0, then sine theta would be 0, and which will give you from this formula the magnetic field as 0. Let us integrate both sides of dB vector to get B vector as shown. So let us do a simple example. So let us compute a small dB vector given a small ds. So ds is given to you as 10 to the power of minus 2 I hat. So here is our small ds vector, and the r vector is given as here, this is 2j vector or 2j hat. So this is the x-axis, this is the y-axis. As you can see, the angle between the r vector and ds vector is pi by 2 degrees. So you convert r vector into a unit vector, so that is you divide r vector by the length of r. So length of r is 2, 2 divided by 2 gives you 1. So r hat is 1 j hat. So current is given to you as 10 amperes. So now you plug it in. So you have I times ds vector cross product with r hat. So this you put as formula as, so this formula is I ds sine theta. This becomes I ds sine theta because magnitude of r hat is 1. So I is 10, this is I, this is ds, theta is pi by 2. And r hat we said becomes 1. We could have omitted this, but we anyway put it in here. So dB becomes mu naught by pi, which we said is 10 to the power of minus 7. You plug in the values, you get that dB at this point. So we have dB at this point, this is given as 2.5 into 10 to the power of minus 9 Tesla. So now you can see the angle is the angle from here to here. This is anti-clock. So the field is pointing out of the screen. So this is the direction of the field is out of the screen.